How's it going, everyone? Eulier Gonzalez again. And today we're going to talk about now is the object-oriented programming, how that works in JavaScript. And this will be the last video since, well, we went through a lot, especially on the async nature, which is a separate and dedicated video to that, and here the object-oriented programming as a way to improve that. And in today's video, we're gonna see now how the class keyword works behind the scenes, what it's doing, and we're gonna write some code to that, of course, and describe what is the mechanism and how that mechanism works anytime you create is an object here. So this course is taught by Will Sentence. Shout out to Will Sentence, which is the CEO of Codesmith, which is a software engineering, machine learning residency headquarters in New York and California, that now wants to kind of accelerate is people that come from different boot camps into senior roles, okay? And for that, you need to pay for your mentors. That's one of the things that this is something critical, because most of us wants to learn or earn things without paying, which there's nothing wrong about it, but it will take you time. And time is one of the most important assets that not only software engineer has, but people has. You can get more than. So playing the devil advocate here is because that's the reason why you should pay for a mentor. And also, because an also advocate is for those who teach content, is that if your content is not providing outcomes to whoever is consuming them, then you're creating is a bad reputation for that. Perhaps you can earn a lot of money, no problem. Ooh, huge amount of money, that is no problem. But after all, we're playing is the long-term game. And that is what separates a lot of people of doing this nifty, sneaky stuff, or trying to get things quickly and take some shortcuts. There is no shortcuts to excellence. One. And that, and second, that's the quickest way to get your name mud for that. Anyway. Anyway. All right, Godfather. All right, so what we're gonna see in today's video is to make a quick recap of the goal of this video, for one, and also the goal of this course. So first, the end goal of this video is, as I mentioned before, is see how now class keyword works behind the scenes, and anytime we use the class keyword, what it's doing for us using the new keyword. And also understand how do we get here by looking is at the ES6 spec of JavaScript on how can we create objects as a way to now build applications that are scalable, which is one of the goal of this, which is the goal of this course, is to see how can we now write applications that are scalable in a professionally engineered environment. And you may wonder why this is important, why do we need to actually provide the scalability to our applications. Again, play devil advocate here. I'm not an economist or a businessman. This industrial age, what has shown us is that when you are now capable to produce things at mass, you not only is providing that good or service to a lot of people, okay, but in the meantime, you are now solving some of their problems or letting them access to things that they will never thought that was possible. So for example, bananas in Iceland or avocados in Iceland, all right? just to mention something, or coffee in Hawaii. Now we give all of this by settle. We give all of this by settle, but there was a process on how now things came to what it is. So this is pretty much the same for understanding now this. How do we get here in the context of software engineer as a way to now describe and improve not only our analytical skills but also our technical communications, the following the best good engineering practice, improving our soft skills. Hey, how empathic I with the other, how patient I am with myself and with others, and lastly is the domain specific knowledge, in our case with JavaScript. Alright, so the course is now laid out on first an introduction of why the OOP is important. Then we move to all of this object creation, prototyping new, scope this, default prototype chain, subclassing, until we reach to the class. So in today's video we're gonna go over all of these concepts briefly, okay, and describe what is the value proposition of each one of those sections. Because now, when we finally reach to the class, we're gonna actually do that by ourselves. So the value proposition of the object-oriented programming is that because in the 60s the computer science didn't have a way to actually organize the data and its functionality into one single bundle. That's why they came out with this idea or this approach, the object-oriented programming. So then, all right, now that we know that, then how can we create objects? Here, as a way to represent is things on the outside world into machine, right? As a way to help us, for example, manage an inventory. So in JavaScript, we have several ways to create objects, okay? Object temp, object literal, object notation. You shouldn't do that, by the way, using the object notation for performance reasons in JavaScript, but that exists. Please don't do that. And we also use the object create, okay, which is a built-in object that provide the language as a way to create now a new object, empty object. And lastly, we have now is the way of how we can create object with functions, which is this particular solution, okay? So because of this is something that anytime you create an object here, which their data is unique, but the functionality remains the same. And the functionality is working on data that already exists. It's working on unique data. So wouldn't be a better way to actually, which this is the value proposition now of the prototype and new, is that wouldn't be a better way to, instead of actually creating all of duplicated functionality for from our objects, we just put that away in one object, and anytime we want to create a new object here, we just only reference to that, okay? We just referencing to that functionality. And that's exactly here the solution to, okay? Where now the solution to, since we can now create this object with the object of create, okay? And this object not only create is an empty object, but also it allows us to modify is the proto, which is a hidden property of the of all objects. And this prototype is the way of how can we now have access to other property and method, or how can we access to functionality in our case, okay? So by now passing is these objects, we are now not only creating a new object, but also is updating it is proto, which holds a reference to this object here that contains our functionality. And this is the sophisticated way of how can we now create objects. So far, so good. So why do we need to go forward, right? Why is that? Well, because the ES6 or the the ECMAScript designer on the ES6 decide to have a go attitude. They have to decide to have an attitude to now, instead of doing this manual reference here, we're now going to, well, put this reference here, and let's go to automate that process. So that's why we look at the prototype, a new keyword. So the value proposition of the prototype is that now we can have a mechanism of how can we access functionality to other objects, or something that they call as inherited. I really don't like to call inherited because what we're doing, especially on JavaScript, is not giving objects. We are not giving objects. We're not giving is reference to this object. In fact, we are creating is a pointer. We are updating is the pointer for that. We have access to this functionality. But again, in any case, this is the prototype. Is a way of how can we have access to data and properties, aka inheritance. And this is very important to understand, because if you come from language like Java or Python, that you might assume how that works, and then you say, oh, but when you try to create object here and follow those object patterns, it's like, hey, this actually, I don't understand what's going on here. What in the French toast is this, man? So the new keyword, what it's doing is that instead of actually you having to manually set the reference of this newly created object that's going to point to the functionality, that's going to now to automate that process. This is known as the sophisticated. Let me actually, in fact, zoom in. Zoom in. Yeah, let me zoom in here. Okay. This is known as the sophisticated way of creating objects. Okay. So with the new keyword, all right. What the hell is this? Why do you show up? Who told you to do that? Anyway. So now with the new keyword, what it's doing is to automating is the process of creation and linking, setting the prototype change for us, which is the value proposition of the new keyword. So now that we have this particular way of how we can create object using is the new keyword, okay, by saying, all right, now we need to define is a function, which will be called function constructor, that inside of this is where we're going to define is, well, how this object is going to be created, okay. This is our data, okay. And then if you want to define some functionality to this object, we're gonna define that under the prototype. So for example, here we are creating is a new user, so user creator, without name and score, okay, and we're adding in some functionality that will live inside of the prototype. And you may wonder, what is this prototype? Okay, well, all built-in, all functions in JavaScript, they are objects, okay, which is now they have this special combo of object portion, and they are functions. They're function because you can call them, and the object portion is the prototype here. So now here in the prototype, which is exclusively or which is for function objects, and if you take a look at the ECMAScript, you can see that now how the in fact, let me take a look at quickly here as a way to describe that. If you take a look at the spec here, now you can see is that abstract operations, no. This is not, but this is the syntax. ECMAScript data type, as you can see, is the object type. Everything is an object, and right below here we get is the fundamental objects. Okay, what we have is the objects, the function, all right, that the function instance contains now things like the length and the name, as well as the prototype. Okay, so function instance that can be used as a constructor and have a prototype property. Whenever such a function instance is created, another ordinary object is also created, and it is initial value of the function prototype. So this is the object portion of this function, right? So we can also have boolean, symbols, and error, but what we care about here is that it exists objects as well as functions. Okay, functions instant. And now how these functions, okay, the function constructor, and now how this functions here has the property that I mentioned, okay, and also here is where you can look at the prototype. Okay, so what are the prototype, or what are the properties that this function, when you create, can have access to? And that is the property of the function prototype objects. Okay, so here you have things like bind, call, and constructor into stream. So this is the way of how now you, when you create a function, can have access to all of these methods, all right? Because it's the proto that holds a reference when you create a function, and holds a reference to this function prototype objects that contain is not only is the prototype, so not only it contains the property length, the prototype length and name, but which is now part of the function object, but also it contains is this reference that points to the function prototype built-in objects that contain now this functionality: apply, call, and bind. And we're going to see why this is important, all of those functions. But this is the way of how you can create functions here, or in this case, objects, using the function constructor and then the prototype as it is. So what will happen is we need to define is some nested functionality inside of this. Okay. So for example, when you need to define is now functionality inside of this function. And this is now when the value of this and the scope is important to understand. Because when you can use this as a way to reference the data, but because the value of this, because after all you want to use this as a way to reference this unique data that is being created to apply this functionality, okay? But the value of this is different in change per context. So for example, in the function, the value of this now refers is to whatever is on the left side, usually, okay? Whatever is on the left side, it refers to that. And the other is that when you define this nested functionality like that, you need this to now work is with the relevant data as it is, right? So because previously we have things like, or we have functions, methods like apply and call and bind that allows is to pass the proper this or set the proper this, set the proper data that we want to work on the this, as under the function context, function execution context, all right, and then pass the parameter. So call and apply, the first parameter it receives is the this, and then the argument, which in the case of call is comma separate values. In the case of apply is as an array. And binds is allow you to attach this value, this on definition, not on runtime. So, all right. So now we know this, and because this feels like a hack, okay. But you have to now hold the value of this in a new variable and then pass that to the proper, and then pass down to the function execution context by using is call or apply or bind. Okay, so instead of doing that, now we have this arrow function that what it does is to create a closure for the value of this, which means that it allows you to lexically now access to the outer functions inside of these functions. So with that, now we don't have that particular issue, and in fact we can now have this nested functionality like this, and if we need to run that. So this is something interesting because that lead us is to now you can think as the new keyword, what it's doing is automating this particular process. It's saying, hey, instead of you having to define is the function constructor on the data and the prototype where all of this functionality will live, we're going now to do that for you using is the class syntax for that. But before going to that, we need to look at something that is relevant, especially if you're going to build all of this application, and that is the first, the default prototype change and how that works, this interlude, and then we're going to see is now subclassing with factory function, and then subclassing with the new keyword, and then subclassing with the class, and we finally wrap it up. So the default prototype chain is something that when you're creating is an object, okay, it actually it points to the prototype, to the object prototype as a way to have access to those properties until it reach to null. So that's the end of the prototype, and this is a way of how now you can have access to all of these property and methods until it reach to null, which is the object building. So the default prototype change, right? It allows us is to, as I mentioned before, access to all of these property and methods, and by doing so, when you look, for example, at the function prototype here, when we look at here at the function prototype, so the function prototype here, when you create a new function here, let's gonna call this foo, and here we're gonna console the log here is foo, right? So this function here, the function foo, we run that, but we don't want to run that. The function foo now is an object that contains it is property of the objects, arguments, color, length, and name, as well as a prototype, which is a confusing name because at the end of the day, this is the portion, the object portion of the function, the prototype, and they have now this hidden property, the prototype, which again it can be confusing because this prototype that is enclosing with those symbols, I don't know what is the sound. What is the name of those symbols? What is the name of this symbol? Okay, list of typography symbols. Yep, this one. Greater than or angle bracket. Okay, yeah, okay, angle bracket, angle bracket, angle bracket. That makes a square bracket. Oh Jesus. Square bracket, parenthesis, curly brackets. Okay, and then you have these angle brackets. Okay, how do you say bracket in Spanish? Yeah, how do you say bracket in Spanish? Spanish? Soporte. Okay. Alright. Soporte angular. Okay. Soporte angular. Soporte cuadrado. Soporte curvo. But let's gonna call this in English. Alright, let's gonna call this in English. Yeah. So angle bracket. Alright. So this angle bracket here, which can be quite confusing because at the end of the day, this is now where the dunder proto-dunder live, which is holds a reference. In this case, it holds a reference to the function prototype object. As you can see here, this is when you can now have access to the property and methods for this particular object, for the function. In this case, this is how you can have access to the functionality. And I say data is functionality because you can have access to this. This is part of the data. So for example, here, you can have access to the apply, or bind, or call. And inside of this prototype, it also holds a reference, all right? The dunder proto-dunder holds a reference to now the object prototype. Okay, to the and this is when the object prototype you have functionality like set property off or has on property. Exactly, it's like has on property, is prototype off, property is enumerable. Okay. And because now, for example, in the case of browsers, they actually change this a little bit. But as you can see here, we can look at the proto. Okay. Here's where we can look at the proto that actually has a pointer or points to the function prototype object. First, they also have is a pointer. You know, they actually are they're changing that name variable. Again, it can be quite confusing, but at the end of the day, is the dunder proto-dunder, or the prototype reference, which actually is an object here, okay? The object of prototype, and this now leads to the object as it is, where now this is the final pointer, which is null. And I think describing this particular process is something that is important, especially as a senior developers, to understand what in the French toast is happening here. So, this is now explaining is the default prototype change. The value proposition of this is that you can see now how all of these building objects, like objects, the object functions, math objects, JSON objects, all of this now have access to property and methods, or it can inherit property and methods, but through the prototype change. Okay, so the proto here is when they have the dunder proto-dunder is when they have a reference to the prototype object, okay, whether it's a function or an object, but this is now how they can have access until they reach to null. You might wonder why this is, when we have this particular way of access to property and data. That's a very interesting question, because after all, we are now having the ability to have access to functionality. Okay, we can define our own custom objects as a way to have access to all of those built-in functionality for that. For example, we can now create our own arrays, right? We can create our own array that when we say, hey, this will be a new array, which their value will be is like 1, 2, 3, I think it is. And then you want to access to this, okay? You will now, by looking at this, not only the data, but also you will have access to the specific functionality of this built-in object, of the array object. And this is something interesting, because this is not only for arrays, this also is for any other built-in objects, whether it's a map, for example, say new map, okay, which is empty initially, right? Which is empty, sorry. Which is, okay, redeclaration of map. Okay, cons map 1, okay. So when you look at the map here, you can not only see it is value, okay, but also is, you can see is the map prototype as a way to have access to all of this functionality that allow you to work with this. And that is one of the beautiful things of looking at this, because as the time goes by until it reaches to the object, that's right, and then the object now points to null. So as you look at this, okay, anytime you have now built-in objects in JavaScript, I'm just going to take a look at the built-in object in JavaScript. Built-in objects, okay. I'm going to take a built-in object in JavaScript here. Where it is exactly standard built-in objects. So not only arrays, okay, but also async generator, something that we're going to talk about that for sure. Big int, you got boolean, you have primitive, okay, and other functionality that the language provide you. So the code UD and code UD evolve functions, generators, something that we're going to talk for sure here in today's video. Iterators, we are going to talk about that, of course, for as well. Parse in, promise. You know, you can now have all of this built in that the language provides. You can have all of these tools ready for you to use to solve a particular problem. And that's quite interesting. That's very, very, very interesting, because now you can reuse previous work of some people that have dedicated time and energy to this as a way to now you can help them build solutions on the internet. That is powerful. So yep, I'm here by the shoulder of giants. Yeah, totally. So now that we look at the value proposition of the looking at the default prototype chain, just to recap, this is the way of how can we reuse previous work or other developers that now have dedicated time and attention to solve or to provide tools for specific needs. Okay, so instead of creating our own solution by ourselves, we can reuse that, okay, and apply that. So building objects like array, map, set, you know, that help you to actually solve common problems. Okay, so for example, hey, if I just want to have these unique values, it's a set object. Hey, I just want to have is a map whose values are not repeated. Okay, unique key is a map. An array, or a math as a way to now generate random numbers. Promise as a way to handle is async operations. And now know how to respond and what to do when something is resolved or rejected, and how now can we iterate is through concept, or how can we now iterate through elements, okay, in a standard way, in a way that we don't have to worry about how can we have access to the data, which is a task in itself. You should actually know how to do that, okay? But once you know that, you usually, as a developer, you care about is what to do with the data. So that's now what iterators allow us to do, is to have access to this data, okay, and run a function. So anytime we run this function, we get the first element. We run the function again, the second element. We run the function again, the next one, until we reach the end of the collection. All of the things that I have mentioned here, even though the other built-in object like the generator, okay, as a way to say, okay, now how can we have control of how these streams or sequence of data are generated, okay, are yielding. So once you understand now what all of these objects are allowed you to do, okay, as a way to solve common problems in JavaScript, now you will embrace the complexity of this. But you first need to understand how all of this works. This is the default prototype, the TLDR. All right. So now that we know that, all right, now let's take a look at how can we now use this prototype as a way to have access or to subclassing, in our case, to generate a new object, and while reusing some of our previous work, okay? So subclassing here with factory functions, that's what it allows to do. So when we use subclassings with factory functions, all right, and that is using the object.create as a way to first define is the data, and then define the functionality, and in the function constructor we're gonna now establish is manually the linking, the link to the functionality, okay? When we now actually want to do the subclassing here, well, the way to do that, which is quite tedious because it's way too manual, unless you want to put a practice that, it's way too manual. Let's say we want to create now is an object called user, okay, or user creator, okay, where now this user creator, all right, this will be is a function, okay, that we're going to do that in the sophisticated approach, which is now manually having to create the reference. That actually will be very straightforward by saying is that, okay, this is the new user. Using is the building object that allows us to, thanks to the prototype chain, access to the create object, all right, and then we're gonna set is the proto here. We want us to now set the proto reference to the relevant functionality for this new object that we're going to create, and that is, well, we're going to define is a function. We can define is that function even below, because when JavaScript evaluate this, it will hoist function, something that is a class are not hoisted, okay? Just to recap here, to remember, here we're going to define is our user functions as an object, where here we're going to say, okay, it'll have the increment, okay, which is this function that we want is to now increment is what? The particular values that we're going to receive, which is the name and the score. Okay, so we want is to now increment is the score. Okay, and then another functionality, which is the login here, by saying, hey, I want you now, in this case, well, console.log here as it is, right? When you say, hey, you're logging, hey, you are logging, you're logging, you're logging. Jesus, I think we did it. Hey, you are logging. Exactly. Hey, you're logging. Okay. And all right. Now what we do is just, well, let's go to create this user. A user one, which is the user creator with the name of Bob and the value of 5. All right. So when we do this, say user1.login. Okay. Where? Oh, of course, because we didn't actually define is the object here. So by running is the object here and say, okay, this will be now the name. In this case is the new user. Okay, the new user dot name, which will be the name, and then the new user dot score, which will be the score, and then we're gonna return is this object. No, new user. Let's do that. Remember to create is the reference to the user function. Okay, and you're gonna complain about it here, but now no longer. You say, hey, missing before formal parameters, line 8. Increment and login. The score. Wait. Syntax. Okay, let me put it this here like so. Oh my god, it's because of course. I see the error. Okay, no, I see the error. Is here. You say, hey, this is now like this, and hey, you're logging. Okay, but how can we now is reuse some of the existing definition here, you know, by creating a new to cover a new special use cases. All right. So in order to do that, okay, we can leave as the user creator as it is, and then create is, let's say, is a function. What we're gonna build is this new user or paid user creator, for example. What we have to receive is the name as well as the score, and then the balance. I'm not gonna dive too much here, but the idea here is to not only call that object here by saying, hey, new paid user, and then now define is and now it's called the user creator, pass the name and the score, all right, and then now it is time to define is the functionality for these objects to point to this relevant functionality. In other words, here we want is to now set the prototype of this new pay user, okay, that points to the relevant functionality, not the user creator's functionality, okay, and those which is the paid user functions, okay, which is an object that it will contain is, well, let's say balance or increment balance, okay. Now we'll have is which is a function. What I want you to increment is the balance here. This dot balance, which is a property that we haven't create, okay, but we're going now is to set the reference to this, okay, set the prototype, forget the prototype of this newly object created, okay, and now link to the pay users functions. And after that, all right, let's now go into new pay user, add the balance property to the balance, and then we're going to return is the new pay user. So when we now create a new pay user, for example, call user, it's paid user one, and we run is the creator or the pay user creator by passing is the alias as a name, then score like 5, and then the balance 10, and when we run is the paid user dot increment balance, okay. I want you to now tell me what is the paid user balance, okay, and now log into the game. Log into the game. Pay user one is not a fun. Okay, exactly. Why this is passing here? Why this is happening? Because once we define is this, we are not is updating is the reference of the pay user option. So what we can do here is to say, all right, now I want you to set the prototype of the pay user the pay user functions to point to the user's functions. And by doing that, you are now linking is that functionality to the user functionality. But as you can see, this is all very manual. It's very manual process. And now we have access to this. This process is very manual. Oh, we are not incrementing that. We can assume that we increment that. But as you can see, this process is very manual. All right. Not to mention is now the approach of subclassing with the new keyword, where just to make our life much more simpler, okay, by saying, hey, saying, gonna wait, okay, so by okay, exactly, CD here. So by saying is a test desktop document is download Google Drive, library, movies, music, picture, public codesmith, front master, remote jobs. I think is CD frontend master. That's right. Here we say is the hard part of OOP. I think it is. Alright, we open this class here as the class example. Alright, in fact, I just want us to get all of this. Okay. Because this example will be is the object create example. So this is the sophisticated approach. Okay, the sophisticated approach. The sophisticated approach of creating objects. And now we're looking here at the sophisticated approach of building object like this. This is now sophisticated approach of creating for subclassing. Okay, for subclassing. Creating a new pay user. Exactly, as it is. And then okay. Name, score, and balance. There you got it. This the balance increment. Alright, and this is now a pay users for that. Again, this is now object create example. This is now the sophisticated approach, and we're gonna take a look now at how can we do this is with the new keyword. Alright, which is quite interesting. In fact, I'm gonna write this down here, or yeah, let's do it. Yeah, let's do it. Now the way of how can we create objects here using the new keyword is by saying, okay, first things first, we need to define is a function constructor. Why is that? For example, let me actually is okay, function user creator. Why is that? Because now the new keyword, which is automating the process of creating an object and linking, create the inheritance, okay, require us to do like this. Create an object here, where now we're going to first set the value of this as an empty object, okay? So you can now is build this object here, name and score, okay? So now you can build this object here by saying dot name, say name, as well as this dot score, and say score. All right, and we're going to define is the functionality is under the prototype function constructor. That's something interesting, because here by saying this is the this is now the we're going to access to the object portion of the function, which is the prototype, okay, that here we can define our functionality. Let's say increment, okay, to say function, okay, and okay, to say function here, the user creator, the prototype, the increment, as it is, and yeah, by doing is this user creator, the prototype, the increment function. We're going to define is the functionality here. For example, like the increment, we say, hey, I want you to now access to this score, this dot score, and well, increment here. I want to define another functionality under the object portion of the function constructor called user creator, which is now the balance, increment, and login here, to say, well, I just want us to now, here is console log, no, hey, you're logging. Hey, you are logging. And when I'm going to now build this object, we're going to define as a user one and say new keyword. It'll do a couple things behind the scenes. First, creating this objects in our function by calling is the user creator function. It's going to create the value of this as an empty object, where you can now add all of these property and methods, and then set the reference of this newly object creator, the proto, the dunder proto dunder, to point to the functions, to point to the object portion of the function, which is the prototype here, and then return the object for us. So that's great, because actually we don't require is this manual linking stuff. Say Alice and 22 is the score. So when we now call is the increment, and I want to actually know what is the value of increments here, user score, and then login here, now we're actually doing as it's supposed to. That's something very, very, very interesting and powerful, my friend. Oh yeah, it is. Oh yeah, it is. So now this is exactly object create example, class example, and this is now the new example. Exactly, new example, the new example, which is this. Okay, so far so good, so no problem with that. So this is what you're gonna see in a lot of code bases. Okay, the current professional way of creating objects. 2024, creating a new user. So far so good, we already create a user. Now when it comes to subclassing here, things becomes a little bit finicky, and your skills, your powers, your JavaScript powers, you Jedi mind tricks, JavaScript power will put a test here. Why is that? Because if we want to create now this new pay user as a way to reuse the previous word that somebody or ourselves we made, now what we can do is this. It's like, all right, cool. So now let's go to create this function creator pay user creator. What we're going to receive is the name, is the score, okay, properties that it needs the base class, name, score, as well as the balance. Okay. And all right. So now that we get this, we're going to do something that we didn't even quite consider that. So here we're going to call the base class constructor or function constructor. Okay, so we're going to call the base class function constructor here, and yep, so we're going to call the base class function constructor here, yep, yeah, we're going to call the base class function constructor here. Okay, and how do you put it? Yeah, so we're going to call the base class function constructor here by saying, hey, I want you to now run as the user creator, but instead of running this, I need to actually because the way how now the new keyword is the work is that, hey, it set the property here, okay, it set the value of this as an empty object, and then is when then after that is updating is the reference for this new object created to the function prototype, and then it return the objects. So we don't have a way of how to control this, okay, especially how to control is the object process creation. But what we can do here is to say, okay, now let's gonna use call, where the first argument it receives is this value, which is this object that we're going to create here, followed by their argument score and balance. All right, and once you do that and once you run that as a side effect, we're not gonna call this the new here, we're just gonna run that function, which will give us as a side effect is this base data, the base object from that, which means in there that is the object being created. You know, first we receive that data as a side effect, okay, and now exactly, and now we are going to define is the values here, like the score and the kind of thing. So now that we have this new object here, that actually is yeah, we have this object here, so we call this object here now we want this to yeah, we want us to set the object prototype here, but it's like, so we don't have to do anything here. We want us to set the prototype of this object here to points to where it needs to points to. Okay, so how can we solve the linking process here? First, let's go to actually define as the property that this will need. Okay, so what happened here first is we're going to call to the base class function constructor and perform as a side effect or an update the value of this as a side effect. That's pretty fucked up, bro. Totally. It's pretty, God, this is totally fucked up. User creator dot call this name, score, and balance. And once you do that, once you receive this object from the user creator, okay, where we update as a side effect, we're gonna add that, and I want you to now is update the proto reference. So before you do that, before you actually updating is the dunder proto dunder, I need to tell you what it will be the reference. So this pay user creator dot prototype, okay, it will have a reference to the user creator dot prototype. Okay, so this prototype, the value, you can have access to the functionality, and then we're going to define is our functionality for this newly created object, which is the paid user creator dot prototype dot increment balance, and then you're gonna do is this. All right, good. It's going to increment balance here. Say balance here. All right, no problem. And when it comes to when showtime, this is showtime to create now this pay new user. Okay, pay new user by using this the new keyword on the pay user creator to pass now here the Bob and 5 as a score and 17 as a balance, and then I want you to now call is the pay new user increment balance. Okay, I want to now sneak I want to pick the current balance here. We can call this 1 1 1. All right, pay new user balance here, and then all right, how are we going to access to the prototype chain? In this case, by saying to the login. So what it's going to do is to first take a look at the option portion. Hey, do we have that? No. Do we panic? No. Let me take a look now at the proto that holds a reference to the functionality, in this case to the proto, to see if we actually have the login. Do we have them? No. All right, but this prototype has a reference, the dunder proto dunder has a reference to, in this case, to the base class function constructor prototype, and this in there when JavaScript look, hey, do we have the login? Yes, do we have them? All right, run it, and there you got it. Mother French toast. And this is now subclassing, bro. And this is now subclassing. Holy moly. This is now the current professional way of creating objects. Current approach, exactly. Current approach for subclassing, 2024. Creating a new pay users, and I think doing this is quite lovely, because with class, what happened here is that, all right, instead of doing all of the things for us, we go now to create a class here, user creator. Okay, instead of doing all of this manual things for us, we're just going to create now here the user creator, and on the constructor, which is the body, part of the body of this class, on the constructor, we're going to receive is now it is parameter, name, balance, no name, sorry, name and score, okay? And here is working the same behind the scenes. It's actually when you run the new keyword is kind of the same, but yeah, it's quite the same. It's gonna call this the function constructor as the value of this. It will initialize the value of this as an empty object here, okay, and then pass the name as name. So we can define is this dot score of the score, okay, and then now take a look at the proto of this newly created object, okay, and I emphasize that this, because this is this newly created object when you use the new keyword. So that proto reference will points to the function constructor prototype. In this case, whatever we define as methods, we just increment. All right. Oh, come on. I know we can do better. We just increment. And here inside of this function, we can have access to the current functionality. We can have access to the current instance data using this. Quite annoying, this. Auto-completion sometimes. This dot score plus plus. And also define is another functionality called login, which is here. Say, hey, console log. And I'm gonna repeat this. Not at all. Hey, you're logging. No. Hey, you're logging. And when we want to create now this user1 here, we say new with the user creator. Now classes are a special type of functions. They are not hosted, okay, and they have a particularly and they have a in overview classes. So they are a special type of objects, okay, which means that it has now this ability to run it, okay, as well as the prototype, which is where we're going to define all of our functionality, which were in the class we define all of our methods. All right. Okay. So classes, the class body can be class body can be organized in or can be characterized by its kind, whether it is a getter, a setter, a method, or a field, by the locations, static and instance, and by their visibility. Is it public or is it private? This is something quite interesting. It's a way to now develop this sense of what's going on, especially when you're creating objects like this. All right. So, because what we are doing here is to define is the fields of this object. Again, now we are actually following is the object-oriented programming approach, okay, which is something that the reason why is the ECMAScript designers decide to implement now the class, or to look like we are writing is classes as an object-oriented programming, because they are ashamed of this prototype nature, and they now allow us to write is this facade class function, right? Or these functions that behind the scenes they're using is a prototype nature, right? Behind the scenes they're using is this prototype nature. Holy moly. It's like holy moly. All right. So here we are, right? So as we can describe here, the user body, it is characterized by three types, whether it's the kind, which is a method and a field, a getter and setter, by their locations, whether it's a static or per instance, and their visibility, public or private. All right. So here is how we can create this new object, okay? By saying, hey, user1 is going to create now the new keyword. We're going to use a new keyword to build this user. So user, create, oh my God, user creator, okay, which is here. User creator, where we are going to where we're going to pass is now the proper argument that it needs to Alice. And then 17 is a score. And again, I want to now, I'm not going to repeat myself. I want to use this user1 increment, user1 score, and there you got it. So user creator is not defined, of course, because that's not the name of that. Is in fact this is user creator as a class, and there you got it. All right, cool. Totally cool. Awesome. Now let's go to take a look at how can now do is subclassing. So if we want to now reuse our existing functionality and provide a new business use case, we can do something like this. A class paid here, user paid creator. Let's say a user paid creator, like this, that now the extend keyword is going to do a couple of things for us, and you call the user creator here. So what is the extend keyword is doing behind the scenes? And I think this is something quite important to recap as a way to understand is this. So because now with the extend, what it's doing, and here we go, because with the extend, what it's doing, even though first, let me take a look now at the extend here. Extends. Okay. So the extend here, according to this, any constructor that can be called with a new and has the prototype property can be candidate for the parent class. The two conditions must both hold. For example, bound functions, proxy can be constructed, but they don't have a prototype property, so they cannot be subclasses. Interesting. As long as you have this shape, as long as you have this function constructor that has a prototype, you can now extend the functionality. Interesting. Exactly. They have a static method for that. So the prototype property of the parent class must be an object or null, but you will rarely worry about this practice because a non-object prototype doesn't behave as it should anyway. It is ignored by the new operator. So extend sets the prototype for both. Oh, okay. So extend set the prototype for both the class, oh my god. So the extend set the prototype of both the child class and the child class prototype, which means that it sets the prototype to the class child. It means that the value of this new object created, okay, is going to point. So this newly object creator and its object is going to point to the base class, to the subclass prototype property, okay, and the child class prototype, and then is going to now set the prototype, oh my god, of the subclass, okay, and then set the prototype of the subclass and set the prototype of the subclass and set the proto reference of the prototype of the child class prototype to the base class. Holy moly, bro. Okay, the right hand side of extend does not have to be an identifier. You can use any expression that evaluates to a constructor. This is often useful to create mixins. That this value is then extend expression in the this surrounding the class definition. Exactly. So you can now have access is to the this definition. Okay, this value in the extend expression is the this surrounding the class definition, and referring to the class name is a reference error because the class is not initialized yet. Await or yield work as expected in this expression. Exactly, because you have to now construct that. So while the base class may return anything from its constructor, the derived class must return. Okay, while the base class may return anything from its constructor, the derived class must return an object or undefined, or a type error will be thrown. Exactly, must return an object or undefined, or a type error will return. So if you do this, it will throw you an error. Type error, derived constructor may only return object or undefined. If the parent class constructor returns an object, the object will be used as a this value for the derived class when further initialization class fill. The trick is called returning overriding. Returning overriding. Returning overriding from the classes, private property. Returning overriding. A class constructor can return a different object which will be used as the new this for the derived class. The derived class may be defined private fields on the return object, meaning it is possible to send private fields onto unrelated object. Because this is per inst, this is static. Exactly, static or per instance. This is potentially a very confusing thing you to do. You are generally advised to avoid returning anything from the construction. Exactly. And you guys don't return anything. But you can do this. And you have to be careful. Which allow the derived class fields, including private ones, to be defined on unrelated objects. But subclassing building. Now we're talking. Here are some things you might expect when you extending a class. When calling a static factory method like the promise.resolve or array.from, okay, exactly static method, static factory methods on a subclass, the return instance is always an instance of the subclass. When calling an instance method that returns a new instance, like promise.prototype.then or array.prototype map. Yeah, when calling an instance method that returns a new instance, okay, here are some things you might expect when extending a class. When calling a static factory method on a subclass, the return instance is always an instance of the class. Exactly. Okay. The returning instance is always an instance of the subclass. When calling an instance method that returns a new instance, like promise.prototype.then, that returns a new instance, okay? When calling a method that returns a new instance, or this, on a subclass, the return instance is always an instance of the subclass. Okay. This is an instance of the subclass. Instance method try to delegate to a minimal set of primitive methods where possible. For example, for a subclass of promise, overriding then automatically causes the behavior of the catch to change. Okay. Automatically cause the behavior of catch to change. Or for a subclassing of map. Wait. Instance methods try to delegate to a minimal set of private methods. Okay, instance methods try to delegate to a minimal set of private methods where possible. For example, for a subclass of promise, overriding the then automatically causes the behavior of catch to change. Or for a subclassing of map, overriding the set automatically causes the behavior of the map constructor to change. However, the above expectations take non-trivial effort to implement properly. The first one requires the static method to read the value of this to get the constructor from construction the returning instance. But again, this is subclassing built-in. The standard committee now holds the position that the built-in subclassing mechanism is in previous spec versions is over-engineering and cause non-negligible. Okay. Proceed with caution. Proceed with caution. Avoid inheritance. I love it. Avoid inheritance. Inheritance is a very strong coupling relationship in an object-oriented programming. It means all behaviors of the base class are inherited by the subclass by default, which may not always be what you want. For example, consider the implementation of read-only, that extent of map. But this is if you are extending this or reusing some reusing some functionality here, and you said that by doing it, it turns out that read-only map is not a constructible because a map constructor called the instant set method. It's not constructible because the map constructor called the instant set method. We might get around this by using a private flag. Exactly. Error a read-only must be set at the constructor time. However, a more significant problem with this design is that it breaks the least-suck substitution principle, which means that if you're going to create the subclass, the least-suck substitution principle say the subclasses that you're going to create may replace the base class. Okay. All right. Which state that the subclass should substitute for its superclass. If a function expects a map object, it should be able to use a read-only map object as well, which will break here. Inheritance often leads to circle ellipse problems because neither type perfectly entails the behavior of the other. Although they share a lot of common traits in general, unless there are very good reason to use inheritance, it is better to use composition instead. Composition means that class has a reference to an object of another class, and it only uses that object as an implementation detail. So in other words, what I'm doing is defining as this class data construction private data here, data get hash t and all of this. This is the subclass. Now it's following is the LISOC substitution. You have this, all right, and in this case the read-only map class is not a subclass of a map, but it still implement most of the same method. Exactly, it's not a subclass of the map, but it still is implementing most of the same method. This means more code duplication, but also means that read-only map class is not strongly coupled into the map class and does not easily break if the map class is changed, avoiding the semantic issue of built-in subclassing. For example, if the map class adds an in place method that do not call set, it will be called the read-only map, no longer be read-only unless the later is updated accordingly to override in place as well. Moreover, read-only map objects do not have the set method at all, which is more accurate than throwing an error at runtime. The whole point of this is that now we are getting into the object-oriented programming, okay? And this LISOC substitution is that part of the solid principle of writing this object-oriented programming, which is single responsibility, open to modifications, open to extension, close to modification. The LISOC substitution, which say, hey, a subclass object should replace the base class. Then you have the interface segregation as a way to now provide is interface from these objects that you can interact with. Solid, and then you have is solid is dependency inversion. Is dependency inversion. Exactly. Is dependency inversion, which is depend upon abstractions, not implementations. Dependency inversion. The dependency inversion principle is a specific method for loosely coupling software models. When following this principle, the convention dependency relation is established from a high-level policy settings models to low-level dependency models are reversed, thus rendering the high-level models independent of the low-level model implementation details. The principle states high-level models should not import anything from low-level models. Exactly. So high-level models should not import anything for low-level models. Both should depend on abstractions, interfaces, and abstractions should not depend on details. Exactly, and it's okay. So they must be. You must create it. So you must not import lower-level models to high-level models, and to do that, you create an abstraction, an interface. But this interface or this abstraction must not depend on details. It must not depend on the implementation. They should depend on abstraction as a way to decoupling the code. Okay. As a way to decouple the code here. All right. Okay. As a way to decouple the code here. The common implementation of deep use similar logic architecture but with different implementation. Package here. exactly, you define is an interface that it can be consumed, that inherits, and here it can reference. Okay, like this high level model, this other model inherit, but new instance has a reference to that. Okay, holy moly. Anyway, but yeah, the extend, this is a very interesting here with what the extend is doing here, because the extend here, any construction that can be called with the new and the prototype, and it has the prototype property, can be candidate for the parent class. The two conditions must be must both hold. For example, bound function, proxy can be constructed, but they don't have a prototype property, so they cannot be subclassing. The prototype property, which is in this case actually using is the new keyword as a way to define exactly its all functionality, all style class. Okay. So it can be a candidate to inherit that. So the prototype property of the parent class must be an object or null. But you really, exactly. So it must be an object or null. Exactly. Must be an object or null. But you really worry about this, because the new keyword ignore this. But extend set the prototype, and when you say the prototype, it can be confusing. The proto, the dunder, proto, dunder, for both the child class, okay, which means that, hey, this child class is going to point to the prototype function constructor child class, okay, and the prototype, okay, and the reference of the prototype object, and the reference of the proto of the prototype reference, okay, holy moly, and the prototype of the okay. Let me actually revisit this. Let me actually revisit this. Exactly, creating subclass with
able to generate an object that does not have functions on it, and user 2 would be very similar, again with the specific data for user 2, but no functions copied on it, but they're still available. This would be it. It'd be pretty nice. But we want to produce a paid user that is just like a user, but a little bit more specific. It has some bonus functions, or so it has some bonus properties, but also some bonus functions that are going to work on those bonus properties. Perfect. Let's see if we can do it. Right-hand side here, here we go. Here we go. I'm just putting this here to show you on the right-hand side.
Creating a subclass would extend exactly like this. This is our final diagram.
Who shall I call on? David. Excellent. Help me out, David. We declare a class which is really a function object combo. Give me a second while I put it on here. Name paid user creator. Hold on, paid user creator, which is a function plus an object.
Oh,
hold on,
exactly.
Oh shit, okay. Now it gets interesting.
Is that an object?
I'm going to use a different color pen for everything that extends does. Use red. Okay, constructor. There it is. And
okay. So we're defining
it
is
has a property
this.
on its object portion, prototype, We know this is our regular stuff, which is itself an object.
An object
into which
in the
we're going to
prototype.
stick what function? So
We're gonna stick is the functionality from the base class, which is increase balance. Okay, let's gonna do this step by step. Let's gonna do this step by step. So first, let's go over step by step. First, exactly. But let's go over step by step. Okay. With this functionality here, which is we're creating a subclass, solution 4, and this is the code here. All right. So here is our code, which is the solution for. All right. And now creating a subclass with extend. The fuck? What? No, chill. Okay. Which is a solution for. Exactly. Which is a solution for. All right. Okay. Okay. And this is our final diagram. But let's go over step by step here. By looking at this code. By looking now at how we're going to do this. Exactly. By looking now at how we're going to do this. Oops. There you got it. Okay. There you go. All right, by looking at this code. So, first thing first. So first, so we are here with our new keyword, which is something that is like, what? What is the new keyword, bro? Accounts paid user here. Exactly, is that we're gonna create accounts paid user one. Say new user user paid creator, It's like pay user, exactly. What? It's like pay user creator. We're gonna pass this the Alice, followed by 10 and 7 as a balance. Okay. Paid user, my friend. Okay. And then we're gonna call this the increment balance. As it is. Say hey. We're gonna call this the increment balance. I want to know what is the balance here from this pay user one dot balance. That's right. And then we're just going to call this the pay user dot logging. One of the grateful thing of the and something that we give by settle is that the VS Code actually now is looking at this prototype change, looking at how the scope of what this property can have access to. All right, and now we know how that works, and I love it, bro. And I love it, bro. Mm-hmm. So we are going to define, okay, in creating a subclass. That's right. Okay. So by looking at this code, we are going to start evaluating is the paid user creator class, right? So far, so good. No problem. You're gonna evaluate that. All right. Good. Cool. So we're going to define is a class object, a class which is a special type of function. All right. What we have now here steps. This is the example, right? Where we hold now here, okay? Okay, where we hold now here. So here we are defining our paid user class or paid user creator as a class which contain is the prototype, exactly, which is a function which is an object that contains is the prototype property. Okay, what you're gonna set is the prototype here, exactly. What you're gonna set is the extend set the prototype for both child class, this new object that is being created, as well as the child prototype here.
David.
Increase balance.
Increase balance. And that's done for us now, rather than have to manually assign it there. It's just done by putting it in the class structure. It's a function.
Which
Okay,
is...
so what does extends do? Extends user creator is going to do two major things. We want any object that comes out of running paid user creator, which will be paid user 1, we want that paid user 1 to have a bond to this set of functions. Well, that makes sense. We know that. That's going to happen by using new keyword, running paid user creator. It'll get a bond automatically to the set of functions in the proto reference. No problem. But we want that object to also have access to this set of functions. So what, when it goes looking in here for, say, name, do we want to happen, Seth? When that object goes looking for, say, name in here, doesn't find it, we want it to go looking...
We're going to look at it as the user creator property.
Perfect. Red means extends does it. So the first thing extends does is set it manually before its proto-link functions. Get a bond automatically to the set of functions in the proto reference. No problem. But we want this, any object...
Okay. Actually, is this one. This is what is relevant for self. Exactly, is this one. That now that contain is the increment balance method in the prototype property. Okay. In the prototype property on our subclass. What the French stuff is this? Which is paid user creator. Okay, so far so good. So what extend is gonna do is to, according to this, is like, all right, I'm going now is to set the proto for the child class as a way to point out to the relevant functionality here under the prototype, and under the prototype and under the prototype function construction of the base class, the proto reference, I'm going to point that to the base class, which is doing is here, the child class of prototype. Holy moly.
Extend user creator is going to do two major things. We want any object that comes out of running paid user creator, which will be paid user 1, we want that paid user 1 to have a bond to this set of functions. Well, that makes sense. We know that. That's going to happen by using new keyword, running paid user creator. It'll get a bond automatically to the set of functions in the proto reference. No problem. But we want that object to also have access to this set of functions. So what, when it goes looking in here for, say, name, do we want to happen, Seth? When that object goes looking for, say, name in here, doesn't find it, we want it to go looking... Its proto-link should link up to it. Perfect. Red means extends does it. So the first thing extends does is set the prototype, setting the object on the prototype, replacing the whole object, and making it have a link through its proto up to that user creator prototype. We did it manually before. Now, extends does it for us. Extends automates that for us. And the bond is made up to there, with the help of extends.
Exactly. So extends here extends set the prototype set the prototype of the prototype, or the under prototype proto, or the ankle bracket prototype ankle bracket Okay, so extend set the proto of the exactly. So extend set the prototype of the oh man, that'd be hard. And I'm not complaining. No. In fact, I can describe that, but I don't want to make you feel sorry about me. That's the whole point of this. Like, that's why I don't describe this too much. Anyway, so extend set the prototype of the prototype of the child of prototype, okay, to the base class. In our case, the paid user creator, okay, the paid user creator of the prototype, exactly, the prototype
But extends does something else. We want to, when we run page user creator with a new keyword, we want to run the constructor portion that we then want it to use the work we did earlier of assigning properties in user creator to use that to help create the object with the right properties on it. Now remember we did that earlier? We used user creator with call and then we assigned the this. We ain't gonna need to do that anymore. Now, inside of the function, the constructor bit, when we run page user creator, creates our object with the help of the new keyword, we're gonna run super. And super is gonna say, go run the user creator bit. It's gonna be a little bit finicky.
All right, much better. And then it will now, with the keyword super, come on, oh really? With the keyword super, run the function constructor of the base class.
See how it does it. We're going to see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains. The super is going to go and take us over to the user creator and run its function to create our object. And by the way, unlike here, where we made the object inside pages creator and then we mutated it one layer out, we're actually going to make the object, wait for this, we're going to make the object inside a user creator. But it's going to have its proto auto set to page user creators functions. We'll see in a second. But that means there's one other thing. Inside a user creator, made the object inside page user creator, and then we mutated it one layer out. We're actually going to make the object, wait for this, we're going to make the object inside a user creator. But it's going to have its proto auto set to page user creators functions. Make the object, wait for this, we're going to make the object inside a user creator. But it's going to have its proto auto set to page user creators functions. We'll see in a second. But that means there's one other thing that extends does. I can't.
Duality here. Classes. Oh my god. Or the extend here. It's like extend. Final semantics, bro. Extending. Don't extend. Rules for extending. Don't extend class foo. That makes a lot of sense. Is from this, oh my god, is from this where you are actually gonna get this. Holy frog. Oh my god, all of this from, oh French toast. French toast. Subclassing. Function prototype. The internal subclassing advanced. These are the objects to make up class person and its subclass. Employee left column and about classes. Exactly. Function prototype of the person and of the employee, right? An object prototype. Object of prototype and the function prototype. Not all objects are instances of objects. Advanced. Prototype change of built-in object advanced. Object of prototype. But how the extend actually works. The internal of subclassing advanced. One of the key to understand how these objects are related is that there are two prototype change. The instant prototype change and the class prototype change on the left. The instant prototype change, right column, it isn't of the, okay. Wow, holy shit. Getter and setter, computer name method, generator method, subclassing. Okay, the prototype of a subclassing. The default subclassing with built-in constructor. The details of class. The detail of subclassing. The prototype change. Oh my god. Okay, this is something that it takes quite a little bit of time. Completely. Holy moly. Oh my god. Yep. 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 Alright. That'll be all for this video. Take care. Bye bye.